So this is our Makey Raspberry Pi Lab. There's actually two different objects in here, but you can interface the two, which is really cool. A Raspberry Pi, anybody know what a Raspberry Pi is? Please don't tell me it's something you use ice cream and cook. No.
I've got about 10 sensors.
Yeah. Nice, yes. So this is a computer. Same as the computer sitting on your desk. I mean, this is a fully functional operating computer. The difference is you don't turn it on and it magically pops up into Windows, right? You have to actually learn, like, you know, us old people had to learn how to like type in command prompts and make it actually do something. And so this operating system, you could swap out different operating systems. You can use Linux. You can use the Raspberry Pi operating systems. You can do all kinds of really cool things. You take this and you plug it into any HDMI monitor and you've got a computer. And it's a really neat process because it's not boxed up into a little box. You have to learn how to utilize its functions, and it gives you a really good understanding about how computers work. Extremely powerful. They're cheap. So like, I mean, this came as a part of a kit, but if I just want to buy a Raspberry Pi, I can buy little ones called Zeros, and I can buy big ones like this that have lots of different features. Ben and I are working on a knockoff called a Banana Pi because it, you know, all kinds of different things you can do with it. It's got different functions built in. But it's just really neat because this is revolutionizing what we do. This is like 100, maybe even 1,000 times more powerful than the computers that operated the space shuttles. And this one costs 35 bucks. You can buy them for 12 for the little ones. They have a few fewer features. But the ability to integrate and utilize these things, it opens up this endless opportunity for being creative. So Raspberry Pis, there's a 1.5 million different types that you can get. The different boards, different chips, different programming languages. But the Raspberry Pi is a very common one. It's also open source, so there's a lot of resources out there for you. So my rule with the Raspberry Pi is very simple. Within 15 minutes, they will realize they can play Minecraft on the Raspberry Pi. The Minecraft on the Raspberry Pi is perfectly legal. You can play it all day long, every day in my STEM lab, as long as you build your own controller. You cannot use a keyboard or a mouse or a game controller. If you build your own controller, you can play Minecraft all day long. How do I build a controller? Your Makey. Okay? A Makey is basically a simplified Arduino that has built-in controls that make key presses. So I can hook this click or space bar or the arrow keys up to bananas, aluminum foil, other people. And the process of using this Makey gives me a way to interface very simply with any computer. Raspberry Pi, Windows machine, your Mac. You plug it in, it's a USB device. That's all it is. So very simply, we use this side. You get arrow key, space bar, and click, and you can build a game interface or any type of controller. Flip it over, and you can start to program every key press that's on the keyboard. You can program and do, and then other features of an Arduino are also possible on here. But this is really cool because it's a very simple introduction to that physical digital interface. We are making physical things control digital things. The other cool part about this is it's extremely highly technical, complicated science behind it. That also is the same thing as our ground fault detection. This thing, all it does is detect a change in resistance. So you don't have to have, like I can't light up a LED light with a battery with a banana going through it. But I can use a banana to change the resistance of this circuit and it can detect it. That's exactly how our ground fault detection system works on the electric grid. This little tiny toy can function, I mean, obviously not as reliably, but it's the same exact thing as our ground fault switches. And so it's really cool because we can introduce these super complicated technical things. As a matter of fact, one of the projects that we have that we do for more advanced settings, not just the 2 weeks, is we give them the schematics, we give them high-speed video of substation switches working and the functionality. We give them the working order for the switches. Like, oh, we're going to change out a switch. They got to go through how to shut it down, how to do all this stuff with the control center. Give them all of that. We give them a Raspberry Pi and a Makey and say, build one. And they have to, so the Raspberry Pi is the digital interface like our Donovan control center. And the Makey is the physical interface like our ground fault switches. And they can build a system that actually physically disconnects a electrical circuit using ground fault system. And it's just really cool because we can tie a project directly into that workforce. And that's extremely important for you as teachers, being able to show where this stuff actually gets applied. And so that's part of the process. So we integrate the Makey in the Raspberry Pi, or you can load up Pac-Man and play Pac-Man on the Raspberry or on the Makey. Our ultimate goal then is with the Makey to get into Scratch and design your own games. Not a lot of that happens in the 2 weeks because, again, I'm not teaching you how to do that. I want you to discover how to do that. There are resources that get kids started in that. They encourage that, so if they have a background, they can do it. But more importantly, what I hope happens is as soon as I take my lab away, those kids will be barking at you all day long to let you, hey, let's make a game. Let's go build something with the Makeys. That's the ultimate goal, is that when the lab leaves, the questions don't.